Hello and welcome to this fifth data collection and pre-processing lecture in this course, Master in Artificial Intelligence. So in this lecture, we will talk about an example. We will take you through an example of gathering relevant data from various sources, ensuring its quality and pre-processing it to make it suitable for analysis and modeling. So this is an example of an AI project based on sentiment analysis of the customer reviews of a project. And there, the goal is to gather relevant data from various sources, ensure its quality, and pre-process it to make it suitable for analysis and modeling. So, how did they start? They gathered the relevant data, and the sources for gathering relevant data included online review platforms, websites like Amazon, Yelp, TripAdvisor, where users leave reviews and ratings for the products and services. They also looked at social media platforms like Twitter, Facebook, and Instagram, where users share their opinions and experiences, and also survey conducted by companies to collect feedback from customer feedback surveys. And finally, public data set, the data sets available on sentiment analysis or customer reviews, such as Amazon product review data set or Twitter sentiment analysis data sets. Then they performed quality check on the collected data. They checked on the missing values, duplicate entries, or inconsistencies in the data to ensure data integrity. Then they validated the data against the ground truth or trusted sources to ensure its accuracy. Then they ensured that the collected data is relevant to the sentiment analysis task and corresponded to the language and sentiment of interest, and finally identified and removed spam or fake reviews that may distort the analysis. Then they pre-processed data to make it suitable for sentiment analysis, text cleaning, and they removed special characters, punctuations, or HTML tags, converted text to lowercase to standardize the text format. Then they split the data into individual words or tokens for further analysis, removed the common stop words like the and is that do not carry significant meaning. And then they reduce words to their basic or root form to normalize variations like running. They limitize to run. Then they converted emojis and emoticons to text representation to include sentiment related information, and finally assigned sentiment labels positive, negative, and neutral to each review based on ratings or sentiment analysis algorithm. Then they extracted data from the pre-processed text data. They converted text data into numerical feature metrics where each row represented a document review and each column represents a unique word in the vocabulary. This is what is called bag of words representation. The cell values represented the frequency of each word in the document. Then they calculate the TF-IDF scores for each word in the document to measure its importance relative to the entire corpus of the documents. And they use pre-trained and word embeddings like world to vec and glowvec to represent words in dense vector in the continuous vector space. So what was done in the BOW representation? In the context of the sentiment analysis projects for customer reviews, the bag of words representation was used to convert the pre-processed text data into a numerical value, numerical feature metrics. Each row of the metrics represented a document, that is a review, and each column represented a unique word in the vocabulary. The values of the metrics represented the frequency of each word in the corresponding document. And this is how the BOW representation worked in more detail. Let's take a look at that. So the pre-processed text data was tokenized, meaning it was split into individual words or tokens. And this process broke down each review into sequence of words. Then they formed that from the tokenized text data, a vocabulary was created containing all unique words or token across all reviews. Each word in the vocabulary became a feature in a BOW representation. Then each document, that is the review, the frequency of each word in the vocabulary was counted. This was done by traversing through the tokenized representation of the document and incrementing the count for each word encountered. And based on the words of count of word frequency, a feature matrix was constructed where each row represented corresponded to a document and each column corresponded to two words in the vocabulary. The value of each cell represented the frequency of corresponding word in the document, and if the word was not present in the particular document, its count was taken to be 0. So let's look at how was this BOW representation look. So here they had 3 pre-processed reviews in this example. The product is great and works well. I am satisfied with my purchase. This product is terrible and doesn't work. These were the 3 reviews. The vocabulary created from the reviews included words like product, great, works well, satisfied, purchase, terrible, does not, etc. Using this vocabulary, they constructed a BOW matrix. And this is how the BOW matrix looked like. Each row represented a review. As you can see, review 1, 2, and 3. And each column represented a word in the vocabulary. And the values indicated the frequency of each word in the corresponding review. Now, so that was the BOW representation. Now, what did the TF-IDF score look like? In the context of a sentiment analysis project, the TF-IDF score was computed for each word in the vocabulary to measure the importance of each word in each review relative to the entire corpus of reviews. TF-IDF scores were used to weigh the significance of words based on their frequency in individual documents and across the entire data sets. So how did this look like? So let's continue with the example of the 3 pre-processed reviews. The product is great and works well. I am satisfied with my purchase. The document is terrible and does not work. They calculated the TF-IDF score for each word in the vocabulary. The TF-IDF score was a word. For a word in the document was computed as the product of its term frequency TF and inverse document frequency. Now, as we know, the term frequency of the word in the document is number of times the word appears in the document divided by the total number of words in the document. And IDF of a word measures how unique or rare the word is across all documents in the corpus. It is calculated as the logarithm of the ratio of the total number of documents to the number of documents contained in the word. Now, this is how the TF-IDF score looked like. As you can see here, I would suggest you come back and take a look at it at your leisure by looking at the PDF file. In this example, the TF-IDF scores were calculated for each word in each review based on their term frequency and IDF. The resulting score represents the importance of each word in each review relative to the entire corpus of the review. Words that are common across all reviews, like product, have low TF-IDF scores, while the words that are unique to specific reviews, great in review 1, satisfied in review 2, have higher TF-IDF scores. What is next? So having looked at the 2 things in this example of how this company did for this analysis, we will look at how they looked at the word embeddings, using how the pre-trained word embeddings like word2vec and glowvec was used to represent words in a dense vector and a continuous vector space in the next lecture, and what further steps they carried out. So thank you so much for watching this 5th data collection and pre-processing lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer, and also download the PDF file especially to take a look at those detailed charts that I had illustrated to you.